Okay, next problem is 5.3. The example: the rotating shaft carries four unbalanced masses, 18 kg, 14 kg, 16 kg, and 12 kg of radius 5 cm, 6 cm, 7 cm, 6 cm. So radiuses are given, masses of all things are given. So we have to create the plane. So create the first, you have to create the table. So that is plane. That is question itself. It is four planes are there. That is 18 kg, 14 kg, and 16 kg, 12 kg. So you take it as 1, 2, 3, 4 are the masses, and 18 kg take it as 18, 14, 16, and 12 here. And radius you have to be write it as radius 0.05, 0.06, 0.07, 0.06. Then next is it is given, and the second, third, fourth masses are revolve at 8 centimeter, 16 centimeter, 28 centimeter measured from the there is a distance is given. There is distance from the reference plane, so that you have to take this distance. So this 40 centimeter, 80 centimeter, 220 centimeter, and 280 centimeter. That is sorry, 40. This is 80 centimeter, on 60 centimeter, and 280 centimeter. That is given in the question. Okay, that is you have to mark it. And also the angular positions are given, that is 60 degree, 135 degree, and 270 degree measured clockwise from the first mass of the shaft. So that we take this one. So for 40 degree, so sorry, 60 degree, 135 degree, and 270 degree from the first mass. We take that. I to draw the angular position diagram. Then it is given the first mass looking for the shaft is dynamically balanced by two masses, both located 5 centimeter radii and midway between 1 and 2. It is located between 1 and 2. So two masses, we have to be balanced these four masses by locating one mass x and other mass y, which is located between 1 and 2 with a distance of 40 centimeter, and another is midway between 3 and 4. So midway, that is why it is 80 becomes 40. So here the midway is 2 280 minus 160 by 2, that is 220. So that you will get that one. So we have to locate that thing. So dynamic, so we have to be dynamically balanced by between 1 and 2 and midway between 3 and 4 masses. Determine the otherwise magnitude of all masses. So you have to find out the magnitude of masses. These are the things given. That is this position of planes is given. So angular position is given. So, and also in the table 1, 2, 3, 4, and x and y masses you have to be find out. Mx and my you have to be find out. The radius is given, and mass, and we know that the centrifugal force is equal mass into radius. So that you will get this one, including mx and my, and also distance from the reference plane. So this is the distance from the reference plane. So how will you find out that thing? So this is x is, you take it as reference plane. So so you take this one. So this diagram, so x from this is negative direction, because it's a reference plane. In this left side direction negative, and right side direction is positive. So x from 1 is 40 millimeters. So that you take it as 0.04 meter. That is right here. And x from x0, x for 2 is 40. Sorry, x for 2 is 40. X from 3 is 120. So here we take it as, you minus it, 160 minus 40. This is 220 minus 40, and 280 minus 40. So that is, you'll write here, and you have to multiply each and everything, so that you will get the this couple, a zero point 0.9 into 0.04 and 0.05 into 0. That is, you will get this 0. So finally you will get this one. So here you know which is the largest value. Again, first of all, you have to draw the couple polygon. So how to draw the couple polygon? So here it is minus 0.036. This is 0. So 0.0036, 0336, 0.134, 0.00 my. So unknown value is my. And this is 0.1728. Which one is largest one? Is 0.1728 is the largest one. So take the scale. So take the scale as 0.1728 is a 5 centimeter. So from that you take it as 1 kilogram and 1 centimeter as like this. So convert all the dimensions from this table. You have to convert, first of all you have to convert 1 kilogram meter square is equal to how much centimeter. So that is fraction 5 by 0.1728. So you have to multiply this 5 by 0.1728 into all this table values, 0.0136, 0.1334, and 0.036. So that you will get the in terms of centimeter. So next is, next is, so they will get the centimeters like this. After that, so you take the length, that is which one? is 0.036. This is minus value, so that we know the 0.036 is equal to how much? 1 centimeter. So that O dash and A dash, we take it as 1 centimeter left hand side direction. So next is the angle is given. So question itself, it is angle is given. You know the angle is 60 degree from the first mass, and 135 from the second mass, and 270 from the third mass. So that based on that, we have to draw the diagram like that. I will explain this after that. This. So first of all, 0.036 like this. Then you take 60 degree and like this. Then again 135 from B like this from the first mass, and again 270 from the first mass. That is 1.17. Then you have to be complete this diagram as 0.00 MY. So I will explain in step by step. So first of all, you draw the 0.036. After that, you take 60 degree. You have to mark B dash as 0.0336 as the second thing. In the table, go for the table. This is 0.036. After that, this 0.036, then 0.034, then 0.0728. Finally, you have to join it 0.009 MY. So like that. Here, first of all, you have to draw 0.036 in the left hand direction since it is negative. Then you take 60 degree. Then you take 135 degree from the first. Then 0.134, you'll get this. And 270 from the again 0.1728 as 5 centimeter. So remaining, you will get the complete equilibrium only when the polygon will be closed one. So that you will close O dash D dash. So that you will get the 0.09 MY is equal to something centimeter x centimeter. Take that or you have to measure the centimeter, and you convert 1 centimeter is equal to how much? This much. So for example, you take the 3.2 means you have to multiply with this fraction value, so that you will get the kilogram meter square. Then 0.009 MY is equal to the somewhat kilogram meter square. So from that, you have to find out the value of MY. Okay. Similarly, you will get the value of angle theta from the direction of the that which one, the reference plane x comes to that. So you'll get the 13.3 kilograms. So that you have to multiply, you take this table. So in this table, mx, you have to multiply 13.3 into 0.005, so that you will get that value into angle. So the remaining only is you have to find out the value of my. So mx is 13.3 into 0.05, so that is centrifugal force. So on unknown value only, here it is 0.05 MY. So that you have to be scale all the things. So which one is largest one? Again 1.12. Okay. So it considers that is 5 centimeter and convert all the scales into centimeters. So that you will get the, again you take zero point 0.9 into 60 degree to 0.84. So like this. Zero point 0.9 into 0 to a 0.9, then 60 degree, then on what that 135 degree from this, then again 270 degree, and the last one, it is this angle, that is O dash D dash, this angle EDE, that is 25 degree. This is the 25 degree we'll get. So that you'll get draw 25 degree with that's scale, then finally you join it. So I'll explain the step by step procedure. So this is a couple polygon we'll get. So this 25 degree, you have to be note it. Finally, we'll find out the force polygon. You have to be use this on as force polygon. So I'll check it. So how to draw the force polygon means which one is largest one. You have to convert that scale and convert all the values on that table, force polygon table, centrifugal force table, to convert that value in centimeters. Then you have to do OA as take it as 4 centimeter from the conversion. Then you take it as 60 degree. So that you will get 0.84 kilogram, that is 3.75 you have to draw. After that 135 degree, that is 1.12. So which what is the procedure behind that? Is this, you take this force polygon. So this is a force polygon. This is a order 0.9. After that is unknown. Leave it. Sorry, 0.9. After that this 0.84. Then 1.12. Then 0.72. After that you take 0.05 mx. After that finally you take 0.05 my. That is 1, 2, 3. First of all, I draw 1. Then I have to draw 2, 3, 4 like that. So that first of all, I have to draw 0.036. This is couple polygon, force polygon. First of all, I draw 0.9. That is OA. Then 60 degree. It draw 3.75, 0.84 kilogram meter. After that, 135 degree with the 1.12 kilogram. That is 5 centimeter. Then 270 degree, that is 3.2 centimeter, that is 0.272 kilogram, that is 270. Final drawing, that is D to E, is 25 degree, which where it is spread from the couple polygons. It is 25 degree, the 0.665. That is, what is that? 0.05 into, which is unknown x value. 0.05 into 13.3. We already get this mx value. So it's substituting, that is 0.665 kilogram meter. So that is 2.96 meter. So that you will get this one. Finally, what is the unknown value my? So you join it, that is you will get the mx or my, I think. So 0.05 mx is equal to something, so that you will get the unknown of mx. So I think it is my. So you'll get the my as 10.81 kilogram. So this is the final answer. So you go through it. If you have any doubt, you have to ask me. Okay. Thank you.